primary concern with the wineries and the fermentation process is the off-gassing of CO2 during fermentation, which is toxic at the concentrations that we're talking about. And in fact, there have been many instances through the years of people actually perishing in the workplace because they have been exposed to the CO2 levels within the fermentation tanks. So one of the things that we would need to design for with those systems is ensuring proper ventilation within that space, wherever the fermentation is occurring, to ensure that CO2 concentrations are maintained at safe levels.
Hi friends, welcome to the Aspire and Acquire podcast. I'm your host Sandeep Suri. Join me for listening to some incredible stories about some of the best professionals from very diverse fields like combat flying, robotic surgery, dancing, tea farming, journalism, deep sea diving, and so on. These accomplished professionals are not just outstanding in their jobs, but also have unique stories to share with us. We have tried to make the show truly global by having these guests from different parts of the world.
Wineries, luxury resorts, and hospitals each tells a different story, serves a unique purpose, and demands its own set of engineering marvels. Wineries need precise climate control to protect the craft of winemaking. Luxury resorts call for seamless comfort wrapped in elegance and efficiency. Hospitals, on the other hand, leave no room for error, requiring systems that support life around the clock. Designing for such diverse spaces takes more than technical skill. It takes vision, versatility, and a deep understanding of human experience. In this episode of Aspire and Acquire, we are joined by Nicholas Kinda, a licensed mechanical engineer who has mastered the art of building systems that serve both function and form. From sustainability to performance and from collaboration to innovation, Nick brings a wealth of insight into what it really takes to engineer spaces that work beautifully from the inside out. So let's jump into the episode. Hey, Nick, welcome to the Aspire and Acquire show.
Right. Great. Happy to be here.
Thank you. It's great to have you with us. And your work about designing innovative mechanical systems, especially for wineries, luxury resorts, and healthcare facilities, is fascinating. And I'm excited to dive into the stories and expertise you bring to the table. So let's start with what inspired you to pursue mechanical engineering, and how did you find your niche in designing for wineries, luxury resorts, and healthcare facilities?
Yeah, so I would say that it started back with just my love of math and science. Through all of my education, I've always gravitated towards those two subjects, and I've always really enjoyed picking things apart, figuring out how things worked. And I would say, as I was going through university and I was actually initially getting more into the physics side, that was kind of the two paths that I ended up narrowing down as my two options, was either going towards physics or going towards mechanical engineering. And I felt like I wanted to do something a little bit more concrete and physical with the systems that I liked working on, as opposed to going towards the research side. So I would say that that's really how I found myself gravitating towards mechanical engineering. How I got into the winery work was actually fairly interesting. I originally born and raised in Napa Valley, which is obviously a destination for wine, hospitality, tourism. But growing up there, it was always kind of a secondary part of the way that I was born and raised. So eventually, after I graduated from university, I found myself back in Napa, and I ended up getting a job at one of the local engineering firms there that really dug in and specialized in the winery process systems engineering. So that was really my first experience out of university, and I really got to dig and sink my teeth into a pretty unique market sector, I would say, especially for MEP consulting engineering.
Interesting. Yeah. And then it just grew up in terms of wineries, and you started going deeper into the subject.
Yeah, exactly. It's at the beginning, it was learning more about general systems, applying the systems designs, and one of the things that I had to really focus on at the beginning of my career was learning the fermentation process, how the mechanical systems that you design for need to help control the systems, control the climate for the fermentation process, which was it was something that I really found interesting and I really grabbed a hold of. So even with all of the other projects that we worked on, I gravitated towards the winery projects because it was, to me, a very unique blend of the technical the technical side of engineering and complex from a systems perspective, but also with winemaking, there's a bit of an art to it as well.
Yeah.
So I found that was an interesting balance between the two.
Fascinating. Okay, so let's talk about your diverse portfolio. I was reading your bio and realized that you have been associated with wineries, luxury resorts, and hospitals. So how do you approach these projects as diverse as these, and what unique challenges does each type of the project present?
So each of the different, I'd say that in terms of the bedrock foundation of the mechanical design that you need to understand as a mechanical engineer, most of the system components, the equipment, things like chillers, boilers, fan pump systems, they're all fairly consistent through each of the different market sectors that you might apply them to. It's really, the key is, like you're saying, understanding the individual challenges to each of these different market sectors. For wineries, it's one of the key factors in designing for a winery is really, it comes down to the climate and the ventilation control. One of the things that is primary concern with the wineries and the fermentation process is the off-gassing of CO2 during fermentation, which is toxic at the concentrations that we're talking about. And in fact, there have been many instances through the years of people actually perishing in the workplace because they have been exposed to the CO2 levels within the fermentation tanks. So one of the things that we would need to design for with those systems is ensuring proper ventilation within that space, wherever the fermentation is occurring, to ensure that CO2 concentrations are maintained at safe levels.
Yeah.
And not only that, but the additional redundancy and resiliency with your systems to make sure that, because as we all know, systems fail.
Yeah.
If you're talking about a life critical system, you need to make sure that that system is going to be able to perform when it needs to perform. So challenges like that, I would say, with the wine industry, there's for the wineries that we would work on, there were typically two different scales that we would be looking for. It would be smaller boutique wineries small batch production, probably what you think of when you think of Napa Valley, where it's limited production for club members. And those design challenges are fairly unique in that most of these facilities are only actually using their equipment for wine production 3 months out of the year, what we call crush in the wine industry. So designing systems that are not only going to be able to perform the functions that they need to, but at the same time not incurring a very large initial cost for the project, for systems that, again, they're only going to be using for a couple of months out of the year, is one of the particular challenges that you need to weigh and battle against with the overall project budget with that scale of project.
Okay. You mentioned about 3 months, can you just elaborate on that? You said, they typically, need it for just 3 months in a year?
Yeah. So what will happen is harvest for the grapes is typically starts about middle to end of August, depending on the year. And really what that, at the beginning of crush, that starts essentially a clock on when the winemakers need to be able to harvest the grapes, pull them into the facility, and begin fermentation. Because they're at the vineyard owners and the vineyard managers, what they're doing is they're monitoring the grapes, monitoring the sugar levels to determine when the precise right time is to harvest the grapes. And as soon as they do that, they need to make sure that they're fermenting as quickly as possible. So bringing them into the facility, destemming them, sorting out any of the additional materials that may be there with the grapes, leaves, dirt, etc., and then getting them into the fermentation tanks. And the challenge there is you only have a certain number of fermentation tanks in the facility, and you've got grapes that are constantly coming in to be fermented. So at the beginning of the season, beginning of crush, you'll be harvesting your white varietals, and you'll bring those in, and those have typically a 21 to 27 day fermentation cycle.
I see.
Whereas red varietals come towards September, October, and those have 8 days. So understanding when you can anticipate those grapes coming in, how long those the grapes need to harvest, or how long they need to ferment, and then making sure that you have all of the equipment and the systems in place to be able to provide. In our design, it's critical to provide enough cooling to maintain that fermentation throughout the process. Because one of the things that occurs during fermentation is it not only off-gasses CO2, but it also is an exothermic process. So heat is generated throughout fermentation. And if you let the fermentation run wild, the temperature of the wine can get too hot for the yeast, which can ultimately kill off the yeast and fermentation too soon. And then you're out a batch of wine that you've been trying to cultivate for the last year. So all of those things play into how you want to design these systems. And then really as soon as crush is over in November, the same systems that are providing the cooling and heating for the fermentation are typically not needed, or the actual capacity that they need is maybe 25%
Oh,
of
okay.
what they need for the rest of the year.
Right.
So sometimes these same systems will be used for the like barrel aging is obviously another key part in the wine industry. Maintaining temperature and humidity within the cave or within the barrel storage facility is something that you would typically also tie in with these systems to provide the cooling, which is a year-long process, but not nearly as much. It doesn't require nearly as much capacity as fermentation.
Got it. Okay. Okay. I want to talk about your design philosophy now. Nick, what principles guide your design philosophy when creating mechanical systems for high-profile developments?
I would say there are maybe 5 or 6 things that really play critical parts in the design philosophy. One of them is just overall system resiliency and redundancy. It's on paper, your design can be perfect. It can be flawless, but ultimately, when they go to install these systems, we need to be concerned with how the system is going to behave at the site and how it's not only going to behave day one, but how it's going to behave day 100, year 1, year 5, year 15, and what's going to happen when systems need to be replaced, need to be maintained, or when systems fail. So weighing the risks of having systems potentially fail in your design is something that you really need to dial in with the project type and with the client to make sure that they're comfortable with the amount of resiliency that you're designing for your system. Another one is the efficiency, just overall energy consumption for each of the components that you're designing for, but also obviously these days the sustainability portion is massive, and weighing that with the all of the different renewable energy components that we have these days: photovoltaics, solar water heating, battery storage, how the mechanical systems interplay with those, and build an overall efficient, sustainable system is a massive part of the job, and it's becoming more and more prevalent, obviously, as the years go on.
Yeah,
there's also the cost is something for the overall project design that you obviously need to take into consideration as a design engineer. Not only the initial costs for the systems that you're designing, but the long-term costs to your proposed mechanical design. One thing that's another interesting part of the wine industry that is fairly unique in terms of considerations you need to have for initial and long-term costs is obviously if you're a new winemaker, a new owner that wants to build their winery in the Napa Valley, you need to have enough capital to be able to sustain yourself for multiple years on end before you are able to even sell your first bottle of wine. Because typically you need to be able to source the grapes, you need to be able to ferment, and then you need to be able to age, which can typically last between a year to 2.5 years. So there's in that project sector, there's much more sensitivity to initial costs because you're not going to see that return on investment for years to come. So designing for that, with that in mind, while at the same time understanding that you want to make sure that you can reduce the long-term costs once the systems are in operation, are components that you really want to work through with the client to make sure that you're dialing in the design to what their comfort level it is for both of those.
Oh, okay.
And then the last two, I would say, the overall experience is, which I call more the artistic component, or maybe the perception.
Yep.
Is something that you really have to work through the design team with and the client with to make sure that you're meeting their expectations. With the wineries, there's, especially in the Napa Valley, there is the hospitality tourism component, and with the mechanical systems, as interesting as I may find them, not everyone wants to be able to see them, to hear them, to you don't want it to be the experience. The experience is, you want to focus on the wine.
Yes.
So you need to be able to take all these different design components, these mechanical systems, and you essentially need to fit them within the architecture that which can be a limiting factor for a lot of these types of projects.
Yeah.
And then lastly, I would say the overall risk appetite for new technologies, pushing boundaries when it comes to the project. You typically want to talk with the client and understand, is this an established facility that really doesn't want to break out of the mold? They want to stick to something that is tried, tested, and true, or do they want to be pushing more towards the cutting edge? We've done projects in the past where one in particular, client wanted a zero net energy water and energy facility, which obviously for a winery presents significant design challenges to be able to ensure that you've got the water available to source, you've got the energy that you're going to be able to produce when you need to produce it. It was a lot of unique challenges with that. So there's projects of all types, different levels of risk appetite. So getting that, understanding that from the client is critical before you even pick up your first draft.
Yeah. So Nick, let's switch gears and talk about luxury resorts now. When designing for luxury resorts, how do you integrate comfort, energy efficiency, and aesthetics into mechanical systems?
So with the resorts, it's obviously all about the user experience at the end of the day. So the same things that I mentioned about the systems not being seen, not being heard, that obviously still very much applies with the luxury resort work. But one of the things that you really try and focus on for the luxury resorts is the efficiency for all of your systems. You think about the cost and energy savings for a resort that's going to be much larger than a typical even winery facility, smaller building. All of those efficiency gains or losses are going to be much greater, magnified in those instances. So one of the things that we will sometimes try and provide is in the industry, it's called more of a campus-wide system
Mhm.
where you can essentially take heat energy from different buildings, different portions of the buildings. Maybe it's guest room units, maybe it's a commercial kitchen that's serving one of the restaurants on the property. And with the systems that are available today, there are ways that you can recapture that heat and energy and move it to different portions of the property. So, and any of those efficiency savings that you can gain from an thoughtful and an intelligent mechanical design are obviously dollars that go back towards the client, go back towards the profitability of the property.
Sure.
So there's that's a large component that you want to think of. And along with that, I remember this was one of the resorts that we were working for in Napa, actually. Something that you also need to keep in mind with your mechanical systems is the time of use that you can expect your systems to be in operation. Obviously, if they're coming to a resort in the Napa Valley, they're most likely going to get up in the morning, they're going to have their breakfast, and they're going to leave the resort to go wine tasting. And which means from a mechanical energy standpoint, the demand is going to peak in the mornings when people are getting ready, taking showers. The kitchen is operational, and then you're going to get a lull in that system demand. And then 5 o'clock, 6 o'clock, when the wineries are closed, people come back to the resort and they want to get ready for dinner. And then you'll see another spike in demand. And understanding those different high energy, high intensity times of use with your system design is critical to make the overall system efficient. Because generally, as a rule of thumb, if your system is going from low percent, maybe 10% operation capacity, and it has to go up to 90% capacity in a short amount of time, it can do it, but it's going to be very inefficient.
Yeah. A sudden spike, will definitely be challenging, I guess. Yeah.
Exactly.
Okay.
And that's something that's very big, in fact, for the renewable energy component, and even the electrical grid, which we can. That's a whole separate subject on the renewables and how, especially California, has been trying to cope with all of that. But it's a fascinating design problem to think about. Not only where you're sourcing that energy, but how reliable that energy source is and what times of day you're really going to need that energy.
And that must be quite challenging, right? I mean, when the spike happens, which you cannot control as a designer, because it is all about peaks and troughs in your customer demand. And that must be a daunting task as well.
Especially for this one project that I was mentioning, it was probably the primary design challenge. One of the particular challenges with this resort was they wanted to have as sustainable a campus as they could, and they wanted to also design the system so it was as off-grid as possible. One of the big stories at the time of this design, which was a couple of years ago, was some of the power reliability for the local utility company in Napa. So
Okay.
they wanted to not only provide a sustainable design, but they wanted to also ensure that they had their own backup power systems. So the system that we ended up helping design was called a cogeneration system. And what that means is there's essentially a gas turbine that generates electricity on the property. And there's also waste heat that's produced from that process. So instead of allowing all of that heat to essentially, no pun intended, just burn away, the idea is to take water, recirculate it through the system, and capture some of that heat so that it could be used to help heat other areas of the property. So for this design, we used it to try and supplement the pool heating, help supplement some heating there was a spa building, so we sent some hot water there, some hot water to each of the guest rooms. So we were able to really increase the efficiency of that plant just by taking that excess heat and moving it throughout the system.
Yeah.
One of the primary challenges with that comes back to the time usage concern with a resort like that, because with generators, more so than most any other system, you really want to keep those operating continuously and as high of capacity as possible, so that you're not ramping the system up and down to meet spikes in that load. So obviously for resort, it was a unique design case because of the fact that clients would check in and they would be away from the property for hours at a time. So that was part of the design philosophy behind installing actually a saltwater battery, which helped absorb some of the electrical energy that we generated from the cogeneration system. And then the waste heat, we tied it in with the pool systems because there's a large volume of water and it can hence holds a large amount of the energy and the heat that's produced. So we were able to map it out, look at typical energy usage for a resort like that, and determine the sizing for each of those components to ensure that not only the system was going to be able to operate efficiently, but it was going to be able to really maximize the return on investment for that for the system design.
Yeah, interesting. Now, if you talk about healthcare, hospitals often have stringent regulatory requirements. How do you ensure your designs meet those optimization challenges for sustainability and performance?
So here in California, there's a separate regulatory jurisdiction that has separate codes that dictate the design for any of the hospital systems. Really, in terms of designing for the sustainability as well as the reliability and resiliency with those systems, it all comes down to ensuring, obviously, that the systems are never going to be inoperational. So in terms of the design components that you typically have to provide, you're looking at essentially duplicate pieces of equipment to be able to ensure that there's going to be a fail-safe or a backup system should one of the pieces of equipment fail. Now, one of the things that if you design your system intelligently, one of the things that you can do is you can actually use that secondary piece of equipment and you can use it to maximize the efficiency of the entire system. So typically, I'll take for example a boiler system. If you've got two boilers, each piece of equipment has a peak efficiency associated with it. It may be when it's running at 80% capacity, 70% capacity, wherever it is, it's got a peak performance curve. And if you have two pieces of equipment, what you can do is you can have a control system set up to where each of the boilers can communicate with each other, and they can help try and track where they are in that efficiency curve. So if there's a, say, large peak in the hot water demand that those systems are experiencing, they can share some of that load with the other boilers, so that instead of one boiler, say, operating at 100% capacity, you could have two boilers operating at 50% capacity to help share that, share the load and operate at a more efficient point in their efficiency curve. So there are things like that you can implement on the design to help increase the sustainable component with especially with these hospital projects. But I would say that the primary design challenge for those is really just the resiliency and designing systems so that they will be able to continue to remain in operation as long as possible.
Yeah. I want to now focus on lessons learned. What are some of the biggest lessons you have learned on such a diverse range of projects?
I would say the lessons learned probably comes down to being flexible with your design. I think that that's a critical component that really allows you to help best meet the client needs when you're working on these projects. There's a tendency for, especially for, I think, mechanical engineers to stick with the tried and true methods and things that they're comfortable with or used to. But the thing that you need to realize is obviously each design is different, and you need to ensure that you're catering each of those designs to meet the requirements for that project. And that really requires being understanding the fundamentals well enough to where you can be flexible with your design. And I would say really be as creative as you can be.
Yeah. Okay. One final piece of advice for aspiring engineers. What advice would you give to young engineers looking to work on innovative and high-profile developments like the ones you have worked on?
I would say the biggest piece of advice that I could give is at the beginning of your career to really dig into the fundamentals of design, and really try and dive into the details for the different design components, the different design strategies, philosophies. There's no way that you're going to be able to see the whole range of building types, market types, project types, especially when you're starting out earlier in career. But what you can do is you can build that really strong foundation that is going to make you successful in no matter what market sector you end up going into.
Awesome. Nick, thank you so much for joining us today and sharing your incredible journey and expertise. Your insights into designing mechanical systems for wineries, luxury resorts, and healthcare facilities have been both inspiring and enlightening. It's clear
Thank
that
you so much.
we truly appreciate your time and thoughtful perspectives you have shared with us and our listeners. Wishing you continued success as you push the boundaries of mechanical engineering and design. It's clear that your innovative approach and dedication to sustainability are making a significant impact in the industry. To our listeners, thank you so much for tuning in. We hope you enjoyed this deep dive into the world of engineering and design as much as we did. Stay curious, and we will see you in the next episode of Aspire and Acquire. Until then, goodbye and take care. Well, in our bonus recommendation section, we are highlighting Abstract, the Art of Design, a standout series on Netflix. We especially recommend the episodes on architecture and interior design, which offer a captivating glimpse into how creative professionals approach space, function, and user experience. If you enjoyed today's conversation, we are sure you will find this series equally fascinating. Happy watching.